Greetings everybody. This video, or actually probably part one of either a 2 or 3 part video, it goes with online lab number 4, and we're investigating something called Newton's universal law of gravitation. And it's an application of Newton's second law as applied to uniform circular motion. And I'll get the lecture notes for uniform circular motion posted on the geography page. I'm going to give you a little bit of background. And basically, Newton's universal law of gravitation applies to planetary motion, for example, the Earth orbiting the Sun, and also satellite motion. And we're going to focus mainly on satellite motion. And one common example is the motion of a geosynchronous satellite. And here, a geosynchronous satellite is orbiting the Earth, and so it's moving in a circle, and it's orbiting at a constant speed, and we call that uniform circular motion. And Newton's universal law of gravitation states that for any two masses, for example, in this case, the satellite would be m1, and the Earth would be m2. And the universal law of gravitation states that the force between those two objects, m1 and m2, the force is given by g m1 m2 divided by r squared, where g is what's called the gravitational constant. In MKS units, it has the value of 6.67 times 10 to the minus 11, and then the units are Newton meter squared per kilogram squared. M1 and M2 are the two masses respectively. In this case, M1 would be the mass of the satellite, M2 would be the mass of the Earth, and r is simply the distance between the center of the two objects, i.e. the radius of that circular motion. Notice the radius of the satellite's motion is indicated by the dotted circle, the dotted line circle. And you see r is the radius of that orbit. And again, we're going to focus on geosynchronous satellites orbiting the Earth. Well, the lab is going to investigate this law. That the force between any two objects in our universe is given by g m1 m2 over r squared. And it's an attractive force. Notice here the green vector f, that indicates that's the direction of the force acting on the satellite. And no matter where, we'll find out when you read the lecture notes, no matter where the satellite is on that circular orbit, the force is always directed towards the center of that circular orbit, indicated by the dotted line circle. So no matter where the satellite is, the force will always be directed exactly towards the center. It's the centripetal force. And so again, F is equal to G m1 m2 over r squared. Well, in the language of math and physics, the universal law of gravitation, it's an inverse square force, simply meaning that the term r squared, the r squared term is in the denominator. And if you graph F versus R, your graph should look like this one here. And now that's what the lab is going to do, is we're going to, the simulation, it simulates the universal law of gravitation. And what we're going to do is we're going to graph F versus R, and also let's look at 1 over F. Well, if F is G m1 m2 over r squared, 1 over F is simply r squared over G m1 m2. Well, notice I'm going to take the 1 over G m1 m2. That term doesn't change. You have your m1, for example, the geosynchronous satellite. You have your m2, for example, the Earth. And you have G, which is the gravitational constant. So that term never changes. So that's a constant. So 1 over F is 1 over G m1 m2 times r squared. Well, let's go ahead and notice I've taken the constant term. It's in the green. So let's take 1 over F and then the constant term, 1 over G m1 m2 times r squared. Let's compare that to y equals mx plus b. And what happens is if you graph 1 over F versus r squared, you should get a straight line, as indicated in the figure. And so So 1 over f is plotted on the y-axis. See the comparison, right here. So you plot 1 over f on the y-axis, then r squared on the x-axis. Well, your slope m should be 1 over gm1 m2. And so, again, right here, your slope should be that. So what we're going to do in the lab, in the online lab, is we're going to, again, the simulation simulates the universal law of gravitation. We're going to collect the data from the simulation. We're going to do the calculations with Excel, do some percent errors, and we're going to do two graphs. We're going to graph f versus r, and the shape should look like this. It's known as an inverse square for us. Then we're going to graph 1 over f versus r squared. We should get a straight line, and the slope should equal the term 1 over, the value 1 over g m1 m2. So that's the idea. So let me go ahead and bring up the template. And here's the template, online lab number 4. Here's the link. So let's go ahead and let's open the link. And here's the lab. Okay, I'm going to click here, play. And here it is. And notice here we have M1 and M2. And then notice we have a ruler here calibrated in meters, so we can determine what R is. So now if you look at the template, you're doing the same thing twice. That's why you have a sheet 1 and a sheet 2. And in sheet 1, for M1, you want it to be anywhere between 100 kilograms to 200 kilograms. And you're going to enter the value right here in C7. Then for M2, you want M2 to be at least 90 kilograms greater than M1. See, M2 should be greater than or equal to M1 plus 90. And then in sheet 2, we're doing the same thing, only I want M1 to be between 700 and 800, and then I want M2 to be at least 150 kilograms greater than M1. So we're doing it for some relatively small values for M1, M2, and then somewhat larger values. All right, so let me go ahead and let me choose an M1. I want something between 100. Let me choose 170. Again, you don't have to use one. It doesn't matter what you use, as long as it's between 100 and 200. Okay, so I'm going to choose M1 to be 170, and then 90 to 260. I'm going to click outside. All right. Now let me go ahead and notice once I entered in. Once I entered, let me undo this. Now notice what happens is when I enter those values in for M1 and M2. Watch what happens to cell K7. Notice right now, cell K7 says dividing by 0. Watch what happens to that cell when I enter in my M1 and M2. So I'm going to choose 170, and I'm going to do 260. Just 170, then plus 90. I'm going to click outside. Now notice right there, what cell K7 is doing is that's calculating the 1 over G M1 M2 term. See, in parentheses it says G M1 M2 to the minus 1. So notice that cell automatically updated. And notice cell K9 also updated. It's the percent error between the slope you get from Excel and the actual calculated value when you just do 1 over G M1 M2. And notice my value for G is entered in cell C9. So just to recap, cells C7 and C8, that's M1 and M2, and then C9 is G. Remember, it's a 6.67 times 10 to the minus 11. And the way you enter that in Excel language, let me go ahead and delete that, is you would do, I'm going to enter 6.67, and then it's times 10 to the minus 11. Well, I'm going to type in the letter E, and then minus 11. That's Excel language for 6.67 times 10 to the minus 11. And then over here, the units, let me pause this for a second. Yeah, so notice when I entered in my value for G, notice in cell C9, Excel automatically put in the correct number of zeros. You got to remember, I entered it as 6.67 E minus 11. And then Excel knows what it's doing. That's the E is the Excel language for times 10 to the whatever. And notice once I did that, it automatically updated cells K7 and K9. Okay, so what we need to do is I'll probably, so just to recap, type in, choose the correct M1 and M2 according to the specifications. G will already be entered in, but if not, you can enter it in yourself. Again, it's simply 6.67 E minus 11. Then just click outside or hit check. Disco. And then cell K7 and K9 are automatically updated. Now, what the simulation does is, let's go to the simulation. So notice, here I have, this is my M1 and my M2. Well, I want to go down here where it says force values. I want scientific notation. What did I say? I want my M1 to be 170. There. I wanted my M2 to be 260. There we go. Okay. Now, notice on the Excel template, your R values are already entered. You're gonna start off again in column B, starting at B13. Those are all the R values that you're going to be. They're already pre-entered. So what you need to do is you need to just set these R values and then record the value of the force from the simulation. For example, and here, how do you do the R's? Well, you can take the ruler and you can set it up with 0 right at M1, and then you just move M2. And notice the ruler is is divided up into units of 0.2. So notice here's 1, here's 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, 2.83. You get the idea. And the first value you want to start at 1.6. So right there. Right now I'm at, see, that's 1.246. So I said I'm right at 1.6, and notice by Newton's third law, we know that the force on M1 is going to be equal but opposite to the force on M2. But notice the force is 1.15 times 10 to the minus 6 newtons. That's for R equal to 1.6. So you go to the simulation. Again, it's a little bit of a tedious process, but it's an online lab. It is what it is. So let me go ahead and enter 1.15 times 10 to the minus 6. So right here, and remember to enter it, oops, you click there, and I'm going to enter 1.15. Now 10 to the minus 6, that's E, then minus 6. And then you just hit check, and there. Then you go ahead to the simulation, you go to 2. Remember, going in increments of 0.4. So now move M1 to 2. 7.37 times 10 to the minus 7 newtons. Or sorry, 7.38 times 10 to the minus 7 newtons. It's, nothing complicated. Go to the spreadsheet. 7 point right here. 7.38. And it was 10 to the minus 7. So E minus 7. Click outside or hit check. Either one works. There it is, and you get the idea. Then you go to 2.4. Again, you're going in increments of 0.4, and you should be able to go up to 8.8. You should be able to go probably even further, but I think we stop at 8.8. That's okay. For this one, we can only go to 8.2. So you can stop at, if you want to stop at 8, that's fine. looks like that's about as far as we can go for, I got 170 and 260. And right here at 0. Yeah, that's fine. So what you'll do is on your spreadsheet, you can just delete these last, you could just go ahead and delete those last 2 rows. That's fine. I was able to go farther when I ran it. I don't know why, and this time I can't, but it's not a big deal. But more than enough values to graph. Okay, let me go ahead and pause this, save this video, and then I'll post the second one where we'll do the values, show you how to do the graphs.